to cover because, and as you can see, I attach a bunch of files on there. Uh, no, what did I have the wrong one? Yeah, okay, I had labeled it the wrong, hold on. One second. Today we're covering the application gateway, which is a huge module. And as you can see, I attach a bunch of files out there for you guys. So we'll go as much as we can do. I'm hoping at least we get about 5 labs done. And we'll go from there. I give you more information than what we're going to cover today, because application gateway is a huge step, because we have to know, you got to do some networking, because application gateway, anything that we're dealing with gateway, we're dealing with IP addressing, we're dealing with all the different aspects of networking, the networking cards, all that, which is for most developers. I know some of you guys are developers, some of you not, but most either developers or programmers and all that, or project managers, we don't really deal with networking on day-to-day basis. So this is a little bit maybe out of your comfort zone, but we are not doing anything complex. I do want you guys to, at least get a hang of what network, what's the networking in the back end, the backbone, as well as understanding the IP addressing, subnetting, all that good stuff, okay? So keep that in mind. Hopefully that this may be something you might not do on a day-to-day basis. Someone, responsible for a networking team will handle it. But it is good for you to know, like I always say, right, knowing more is not going to hurt you. Only knowing less is going to hurt you. So it is good to know as far as for troubleshooting, because majority of the issues that that even reported to Microsoft is always related to networking. So that's why, I think this module is going to be a important module for you. And if you go forward and go for a certification or anything, networking is going to be huge that you have to know networking, or you're not going to get any certification, any type of certification. Either you go for the architecture or for the administration or for the developer certification. So, all right. So we're going to talk about Azure networking components. And networking itself is a very complex topic to begin with, but now we're talking not a regular type of on-premises networking. We're talking about Azure networking, so which is even make it a little more complex here. Virtual networks, we start with the virtual network. So you have to have a virtual network before we can go dive into the gateway, because the gateway is going to run on top of virtual network, okay? So virtual networking, we'll talk about the subnetting. Subnetting is very, very important. Every organization, when you purchase IP address, you are going to subnet it within your, within your company. We'll talk more about it. We'll talk about how to implement a virtual network, how we're going to, in a particular virtual machine, on one virtual machine, you can have multiple NIC cards. If that virtual machine is having 2 or 3 different type of duties. For example, that virtual machine can be a web server. That virtual machine also is hosting a web app. And that virtual machine is also have database on it, SQL database on it. For each function, you will have a separate NIC card. NIC is Network Identification Card. So every PC that we have in your organization, as well as you have on your laptop or desktop, has a NIC card. That is how you identify a computer on the network, is based on your NIC card. That is your Network Identification Card. So we'll talk more about that. So in a networking, Azure networking components here. So we have virtual network, load balancer, Azure DNS, VPN gateway, express route network watcher, traffic manager, content delivery network, which is CDN stuff, and application gateway. All of these components, there's 9 components, as you can see. You have to be able to deploy all the 9 of them on top of a virtual network. So these are all the different functionalities that we're going to go through. We will do a load balancer, application gateway, Azure DNS, traffic manager. The other ones, I'm not sure we get to that, but even though if we don't get to the other ones, some of the other topics, I'll make sure that you do have the documentation for that, all right? So Azure requires the same type of networking functionality as on-prem infrastructure. That's what I was saying. Azure Networking offers a wide range of services and products. The only good thing with Azure Networking components, not like on-prem, you don't start from scratch. These built-in tools that give you a template, so we just have to fill the template like we've been doing. There is a back-end code that's going to handle it. And in virtual networking, we don't have to worry about, of course, the wiring and all that, the router stuff. We don't have to worry that that's the backbone. Microsoft will handle that at the back end. So those are the good stuff. But still, if you're new with networking, this is kind of a little bit undaunting type of test here. So in the virtual network here, so this is a particular virtual machine, like I said, it has 2 different NIC cards. So you can have multiple NIC cards. So this one is one NIC card represent going to on-prem, and one NIC card is used to go to virtual network. Logical representation of this, your own network, create a dedicated private cloud only on VNet. You can securely extend your data center with VNet. So even though you have an on-prem, so a lot of organizations are using on-prem as well as we're using Azure Portal. If you're doing both, that's what we call a hybrid. In a hybrid type of environment, the virtual network becomes very, very important, because virtual network is going to connect straight to your on-premises, and on-premises servers are also going to connect to the virtual network directly. So you have your own private line. You're not going over the internet to connect to servers or servers in the on-prem as well as vice versa. So virtual network is very, very important. So, okay, so under a virtual network, so everybody know IP address, right? And so IP address is another one that identify your computer out on the network, that identify that, okay, no 2 PC is going to have the same IP address. You cannot have IP address is like our home address, right? For my home example, if my home address is 12234 Deersong Drive, there is no other address with 12234 Deersong Drive with the state and the zip code. You only have one, right? So that's how we get mail, because they know that this is my address. So same thing, IP address is your home address, similar to home address for your PC. So there is 2 type of IP addressing we have. We have IPv4. We've been using for years. That's 20, 30 years ago. We have that IPv4 addressing, which what we see here is 4-digit. That is IPv4 addressing. More and more, but so at, I think, early 90s or mid 90s, IPv4 addressing are running out. So the way is that every organization, when they have any organization that has computers, is planning to do a network or any type of communication to the outside world through either VPN or Telnet or RDP or internet. You have to have IP address. So that's how they identify. So they had to purchase the IP address from there is a global, worldwide organization that sell IP addresses. They make sure that no 2 company has the same IP address. Okay, so IPv4 addressing. So if I wanted to, I have a new business and someone come to me and say, I want to set up 200 computers, I will have to request IP addressing from this organization, and that organization says, okay, you need 200 IP address. This is your IP address range. So 10.1.0.0 to 10.1.0 blah blah blah. That is my IP address range. So I have IP address for 200 IP address. That's what I paid for. So, however, let's say if I have devices on my, all right, you get printer devices, you have other devices, you have routers, you have switches, any other devices, also need an IP address. So even though I purchased 200 IP address, what I do is that I can use subnetting to get more IP address. So that's what we do is subnetting for. So even though I only have 200 IP addresses, when I subnet it, now I may come up with 300 or 400 IP addresses. However, that's within your organization. But if you go out from your organization, if you go on the network, you go out to the internet, your IP address has to be unique. In the entire world, nobody has the same 2 IP address. So it has to be unique. So that's where gateway and stuff comes in. So, but here's the subnetting we're talking about here. So there's multiple subnetting. That's IPv4 addressing. And mid-90s, IPv4 addressing are running out because more and more organizations, of course, as you know, every day are purchasing IP address. So they came up with IPv6 addressing, and we don't really deal with IPv6 addressing. But if you see an IP address has numbers and characters like F, and they have colons, double colon, that is IPv6 addressing. So IPv6 addressing has also 6 digits. So here we have 4, we call 4 block. They have 6 block, and they can go higher range of IP addresses. Anyway, so long story short on that. The virtual network can be segmented into 1 or more subnets. Subnets provide logical division within your network. So subnets, think of it as like a subfolder, can help improve security, increase performance, make it easier to manage the network. So each subnet must have a unique address range. They cannot overlap with other subnet in the virtual network. So when you go into the virtual network, notice that there's 2, even though they're both /17, this is 10.1.0.0 range. This is 10.1.128.0. So that's a different subnet. You break it down to multiple subnets, and each subnet has their own range. Within your network, you cannot have overlap. And again, we're not doing a networking. This is not an IP addressing class. However, if you're the person that needs to be responsible for setting up virtual network, you do need to look into IP addressing. You need to make sure you understand the IP addressing. And more organizations are starting using IPv6. So you also need to know how to subnet the IPv6 addressing, okay? So create a new virtual network at any time. Add virtual network when you create a virtual machine. Every virtual machine when you create it, you have to create a virtual network. How do we connect to that virtual machine is through the network. So you must have a virtual network. You need to define the address space and at least 1 subnet. So this, be careful with overlapping address spaces. So before you go in to start creating virtual network, your organization, if you are the responsible person, networking architect is going to define how many address space that they purchase. Well, he'll know how many you guys purchase for your organization, and will also know how to break down different subnetting. So you'll get more IP addressing out of what you purchase. So normally they'll tell you, okay, these are your subnet range that you can use, and this is our address space. So that, if you're not a networking person, in a production environment, you do need to talk to somebody. You can't just start creating virtual network without having a plan, because IP address range can overlap. This very easily happen, and that's majority of the problem is, like I say, 80% of the problem that report to Microsoft has to do with networking. So you can see, how networking is. So if you have a multiple NIC card, which is NIC card is network identification card. So notice that here, this a virtual machine, Azure virtual machine we created 2 NIC card, well, we have 3 because there's a default, NIC card 1 and NIC card 2. So we have 3 NIC network card. Each network card represents a different role. So the default network card is a front-end subnet. It is communicated. If you want to go out to the internet, you have to go through this, the front-end subnet. Then we have a middle tier subnet, and we have a back-end subnet. So if you wanted to go out to the internet, this is what you're dealing with. Notice that the going out IP address is 133. These are 10.2.3, 10.2.2, 10.2.1. You cannot overlap. And if you want to go to cross-premises community connectivity, you're using a VPN gateway to go to your on-prem. This is where you're doing through a VPN gateway. So it's a lot more. And think of it, a gateway is like when you if we go to a show, right? If we go to a show, when we go into the show, we already purchased a ticket, but when we get to the gate, we have to show our ticket, and they're going to verify that ticket is It is correct, and they go through, that's how we authenticate and authorize and say, okay, so look at the ticket. They say, okay, this is a valid ticket. And then in the ticket, they can tell you what row, what seat you need to be in, right? So that's what similar VPN gateway is. VPN gateway is going to check the source IP address coming from and where do you want to go to. And then it's going to check that, yes, okay, this IP address of 10.1.8.110, you do have permission to go to this particular server. So that's what a gateway does. VPN gateway is pretty much making sure that only valid transaction can go through. So that's what the bottom line of the gateway is. Setting up gateways is a little different, a little more complicated, but that's what it is. And we will set up some gateways today. So we're talking about IP addressing, public IP address, private IP address, service endpoint, services, source access to storage. I'm not going to make a big deal of IP address. I think we talked about enough on that. But IP address also, not only that we have the IPv4 and IPv6 for the rest of the time we're talking IPv4 only, because majority of organizations only have IPv4. And some of them and newer ones might have some IPv6 addressing. So for any Azure resources, which we created many of them, we had created a VM, we had created a storage account, we had created a web app. Right throughout these sessions, we've done it. All of them have two types of IP address. We have private and public IP address. So public IP address is, we're talking internet or public facing services that if you're going out to Facebook or any social media or any type of third party tools that are not in our organization, out of the organization, or you go to a vendor site, those are, we call it public facing services. In order to go out to the internet or public facing services, you must have a public IP address. Without public IP address, you cannot go on the internet. That's how they identify who you are on the internet. Then we have private IP addresses that you create virtual networking, the on-premises networking. So this is private, is within your organization, creating gateways, express route. So there's a lot of fun stuff that we'll do today. So there's two types of IP address, public and private IP address. And this is, they're talking IPv4 addressing here. Public IP addresses. So IP address association is with a NIC card. Is dynamically, you can have a dynamic IP addressing or static. For a load balancer, which we'll create some today, load balancer and application gateway, we're going to create both of them. Those are front-end configuration. It is dynamic and it is static. The only one is not static is VPN gateway and application gateway. These are all different things that it can be associated with. That's a public IP we're talking. Now we're talking private IP. So in private IP addressing, the NIC card, the virtual machine internal load balancer, application gateway, all of them can be both dynamic and static IP addressing. Service endpoint. Service endpoint is very, very important. I know we see by now we've done a bunch of service endpoint in the labs. Now we may not know what service endpoint is saying. So endpoint limit network access to specific subnet and IP addressing. It improves security for your Azure service resources. Optimal routing, we'll do routing and traffic manager stuff later as well. Azure service traffic from your virtual network. Endpoint use Azure backbone network. So I said Azure has a backbone network for us. We don't have to set up routers and things like that. That's down in the back end. To set up with less management overhead. So service endpoint, instead of using the Azure services, which is, again, Azure service can be a VM, it can be a storage account, right? It can be a blob storage, it can be file share. All of those, we use a service endpoint. So service endpoint is like so service endpoint is a built-in tool for you, so you don't have to create it from scratch. We're not creating a service endpoint from scratch. There's Microsoft Storage, Microsoft Azure Active Directory, Microsoft Azure Cosmos DB, Event Hub. Those are all considered service endpoints. So pretty much a direction that where you wanted to go to, your destination where you want to go to. You can write from scratch, or you can use one of the existing templates. Okay, service access to a storage endpoint. So you must configure both sides of the endpoint if you're going to use the endpoint. So you have to, the virtual network site as well as storage account site. You have to create both. You have to have both of them. It has to have an endpoint. So here we're talking is selected networks. We use a configure network security for the storage account. A virtual network, we have my VNet, our virtual network. We have one subnet, it tells you what your address range is. We have a subnet, and my subnet, another address range. Endpoint status is enable. So each endpoint, one thing they will say, each endpoint has their own Azure documentation page, so you can look at them. But pretty much endpoint has information on how to connect and from one machine from a source to destination. All the details how you're connecting, that's in the back end, and that's what endpoint is. Azure DNS overview. Okay, like I say, before we even get into doing application gateway, there's two things at minimum we need to know is how to create a virtual network and understanding how the IP address range works, as well as we need to set up Azure DNS, Azure Domain Name Service. Because within the network, it doesn't matter if you're doing on-prem or on Azure, you have to have domain. The domain is that how we organize our networking group. We have to have DNS zones, DNS record set, DNS delegation, DNS for private domains. So these are all the property of a domain. And what is a domain? So your organization will have a domain, or even Microsoft or Microsoft.education.com. That's a domain. MicrosoftUS.com. That's a domain. These are a bunch of domains out there. So what does DNS does? DNS is a domain name server. It is a name resolution because most people that are connecting to a server, either on-prem or on the virtual machine, in Portal, we're not going to know the IP address, right? For most end user, we're not going to know the IP address. We're going to know the name of the server. So example, we're going to say, okay, SQL Server 1. Okay, I want to connect to SQL Server 1. I know the server name, but I don't know SQL Server 1 IP address. I'm not going to know that. So that's where domain name service comes in. So when I send a request from my client machine that I want to connect to a SQL Server, on Azure, on one of my VM, I have a SQL server. If I want to connect to that, I know the server name, but I do not know the IP address of that server name. So before it goes straight to my request, instead of going straight to the server, it's going to go through the DNS server first. And DNS server is going to take that SQL Server 1, the name that I requested, the name that I asked for. It's going to say, okay, SQL Server 1, what is the equivalent IP address for that SQL Server 1? So it's going to go look up in the domain name server. There's like a table, and the table is going to go look what is that IP address for that server, and it's going to translate it to that IP address, and it's going to use that IP address to go out to the network, So that's what DNS name, it does. It resolved a server name to an IP address. That's the simplest thing. That's what it does. So in this demo also, when we do the lab, we are going to create custom domains. So you can also create custom domain. So notice that to create a directory, organization is Contoso Gold. Initial domain name is Contoso Gold. Always going to be at .onmicrosoft.com. That is going to be always append to it. But I can also create a custom domain name called contosogold.com. So this is okay. So once we decided that we're going to use DNS and all that, first thing we have to have is a domain, and you can create a custom domain. Which any domain that if your organization have a given name, those are custom domain. So, but if you create a custom domain is also very important. Throughout the entire world, you cannot have a duplicate domain name. So in order to make sure that we don't have duplicate on the on worldwide, what we have to do is we have to register your domain. So it's going to see that, okay, do you register there as an organization that we register the domain to make sure that there's no duplicate. So when you go through that process, they're going to verify that that domain is available that you can use. So most of us, like, if you use your name, most likely that domain is going to be available. But as well as I do, so many organizations, so many companies out in the entire world, they're going to have, most of the domains, are popular domains, are going to be gone by now, right? So here we're creating, so we have to decide what custom domain name is going to be as an organization, and once we know that, then we're going to have to register that domain name. This is what we're doing. When we register the domain name, you have to give a DNS record. You can add MX or TXT, so it's to kind of tell you, do you have an alias or host name? What is destination or point to the address? So time to live. So these are all different information. Again, we're not now in class, I don't go in detail, but I want you to know that we have to create a domain, and in the domain, we have to add a DNS record. That domain name server record, that is what's going to translate. That's what's going to get stored in the DNS in our domain name server, and that they know what your domain, they know where your domain is, they know what the domain address is, so you have to make sure you have to register it. And this can take several minutes to several hours. Trust me, we're not verifying anything today. We will do the verification on that. Then you can, once you have your domain, then you have a DNS zone. That's going to host that DNS record that we're just saying. We just created for a domain, specific domain. It's going to store those addressing for us. So here we have, in the DNS zones, we have addendum.net and gwckatoso.com. So these are different domains we have in our DNS zone. Where multiple zones share the same name, each instance is assigned different name server addresses. So if you have, we create, for like failover and all that, we can have a different name server address even though they have the same name. So the only one set of addresses can be configured with the domain name registration. So you would have your primary domain name is the one we register. So talking about this is DNS record set. A record set is a collection of records in a zone that have the same name and are the same type. You can add up to 20 records to any record set in each record set. A record set cannot contain two identical records, of course not. Changing the drop-down type, chaining the drop-down type changes the information required. We are going to create all of these, so don't worry about that. Here, we'll get you to do that. Now, when you DNS delegation, so when delegating a domain to the Azure DNS, you must use the name server to provide by Azure DNS. So the name server, when you create a DNS, it's going to say that you have these 4 name servers that you can use. So notice that if you're looking at, this is standard. We're not just talking because Azure. If you register a domain, this is what always happens. In the real world also, you have they give you the .com for that particular same domain name, .com, .net, .org, and .info. So when you create when you register a domain name, because you've got to create a website and you register a domain name, they're also going to give you all 4 of that, the .com, .net, .org, and .info for that same name. So each domain name is going to have 4 different type of name servers. We call those name servers, 4 different name servers. Most of us are more familiar with either .com or .net is what we heard. .org, that's for more government type of situation, and .info for more charity organization use the .info. So then we also have DNS for private domain. You can also use your custom domain, and we talked about that earlier. Provide name resolution for VMs within a VNet and between the VNet virtual networks. Automatic host name record management. Remove the need for custom DNS solution. If it's if you're using private domain normally stays within your organization only. So you're not going out to the internet. So this is the client VM. We requested a request is db.katoso.local. So it's going to go out to the DNS server, respond with a private IP. You're going to use that private IP to connect to the resources to another server or whatever you're trying to connect to. But this is all happen in-house is what we call. It doesn't need to go out to the internet because and this is in the same virtual network. You're not going out from your network either. All right. Then we also have private zone scenarios. So we have two, we can also have VNet 1 registration. As VNet 1, we have two VM registered under there. We have query vm2.contoso.com. It goes out to the DNS. Also, we can have a resolution server. It's going to respond back to DNS. DNS is going to respond back to the client. So DNS resolution in VNet 1 is private, not accessible from the internet at all. So DNS queries across the virtual networks are resolved because you're internally. Reserved DNS queries are scoped to the same virtual network that you're in. So again, I know this is maybe a little too much detail that you want to know, but we do need to know somewhat, even though we may not set this up. I want to make sure that you're familiar with the terminology and at least have a good idea that what they're doing. All right, network security group. Okay, so we also create a network security group so that to make sure that our virtual networks are compliant with law and internal your company policies as well. So you can limit network traffic to resources in a virtual network using network security groups. So here it's saying that security rules, we have 1 inbound, 0 outbound. You can't go out. You can only, this particular policy says that you can only connect within your network only. You cannot go out. 0 subnet, 1 network interfaces. You can limit it, what you want to do. Network security group contain a list of security rules that allow or deny inbound or outbound network traffic. Remember when we were creating a VM and if we want to do remote desktop, we said we have to enable the remote desktop and we tell them what IP, what port number we want to use. That is in the back end, that is a security rule. Okay, so if you don't set that up, we can't go out to, we can't connect through RDP to our VM. Associated, so NSG, Network Security Group, associated to a subnet or VNet or network interface card. All right, so NSG rules, so here you can see that inbound and outbound rules. We have, okay, allow VNet inbound, any port, any protocol. Allow Azure load balancer inbound, port, any protocol. Deny all inbound. So you can see that there's inbound and outbound. Each of them you can specify a specific port number, specific protocol, and we can say actually can be allow or deny for both inbound and outbound. Inbound is staying within your network. Outbound is going out to the internet. Going out over the internet somewhere. Okay, you can also have these, we also call these, there is a effective security rule. When we go into the lab, you'll see that effective security rule. So evaluated independently for the subnet within the NIC. Allow rule must exist at both levels for that traffic to be admitted. So this is more secure thing, and if we have a sensitive data stuff, we might do this. We have two different network security group, and both network security group has to approve if they're allowed this particular permission. If you, whatever permission you're trying to do, let's say I'm trying to update a record in SQL database, it's going to look at the rule 1 and rule 2, is that okay? If rule 1 and rule 2, both of them I have a permission to connect to the database and update it, then it will let me do that. But in Network Security Group 1 policy, they say that yeah, you can update and create anything you want in the database may. However, if Network Security Group 2 saying that no, you cannot. So anything that, so they both have to agree. If one of them saying that you cannot do something, you're not allowed a particular permission, that will override the other. So we're doing a double security. So think of it like when you go to, come to my house, if you have two doors instead of having one door. So you have to apply two different rules to be more secure. Not sure which security rules are being applied. Use the effective rules link if you're not sure what security rules are being applied on that. If you already have one, but we're not sure. I didn't create the Network Security Group 1, so I'm going to reinforce it with Network Security Group 2 to make sure that someone not supposed to have permission not, or someone who's supposed to have allow permission also have. So that's what effective security rule does. And we can create the security rules, which we'll do some today. We have service. We need to tell what the destination protocol and port range for this rule. We have to say destination, are we connecting to a database? Are we connecting to SMTP? Are we FTP? Any of these services. We also, you have to know the port range. Single port, or you can do multiple port. Port range is 8080. That's for internet security. Regular internet just going without security is port 80, right? So, and then we have to set the priority. The lower the number, the higher priority is. And there's just a name for this, this particular security rule. So if you're not sure what the port range is supposed to be, that's pretty much standardized. You can go look at, go on internet, go to Google, you can pull what type of port number. You also want to work with your network administrator, or the network architect should tell you that from the very beginning what port ranges are, other port ranges, especially 8080, of course, that's standardized to go on the internet, but locally within your organization, port numbers can be, they can choose a different type of port number. So you wanted to make sure you talk to somebody and make sure that that port is available for you to set up a network security group rules. All right. You're done hearing me for a while now, right? So the first thing we're going to do is create a virtual network. And you should have a documentation that that I have given to you guys. Okay. So this is what we're going to do. We're going into the lab is the DNS setup is the one. We have to set up DNS record before we can create our virtual network. So that's what we're doing. So if you guys can open up that lab DNS setup. Oh, come on. We don't need file. I guess I must have it open already. Okay, I do have that. I don't need this one. Go away. Go away. Okay, so before, as we always do, before we go in, we're going to look at this. So these are the files, 100.4. I put in all these files. You should have those files as well. I gave you guys all the lab files. And these are, so we are going to use 100 for B01, 4B02, and 100.04. I just want to make sure. So before we go in, can you guys locate that you do have these files? 100-04B01, 100.04B02, and 100.04 for the parameter. Do we have that 3 file? I'm going to go grab my refill my coffee, and I'll be right back. See if you guys can locate that 3 file before we start. Okay, I hope everybody able to locate these files, right? because it'll be very hard to do the lab without these files. All right, let's look at what we're going to do. So we're going to configure the Azure DNS domain name server for public domains. So we are going to create a public DNS zone, and then we are going to create a DNS record in the public DNS zone. We create a resource group. We're going to add a record set to our DNS zone. Then we're going to validate that DNS base name resolution for the public domain. So after we do that, this is where now we're going to start going into public domain. Then we do private domain, because we need to make sure you know how to do both. And we are provisioning a multi-virtual network environment. This is our backbone. We have to have the DNS. We have to have the virtual networks before we can create our application gateway. All right, so we are doing this in the portal for the public, and for the private, we're doing it in the Cloud Shell, right? So we are going to deploy those Azure VM into the virtual network, because we have the VM that's standing alone. They are not in our virtual network, so we're going to put them into the virtual network. We're going to validate that DNS-based name reservation and resolution for the private domain is working. We can verify the domain. So that's the two things we're going to do. So this is just a base. We're building it. So the next thing we can do is go in and create virtual network and all these different stuff that we need to do so we can create our application gateway. So this is our first one to get us started. Without the DNS, we cannot create our application gateway. So make sure we are logged into the portal. I had to delete everything I have in there so won't have any confusion. So once we are in the portal, I am already in the portal. Hopefully you guys are as well. And we're going to click on create a resource in the new blade, because they want us to have DNS zone. So as long as you just type DNS, the DNS zone will come up. We select the DNS zone. Again, this is in the portal. And then we are going to click create. Right, so when we create the DNS zone, the name, we need to have a valid DNS domain name in the .com namespace. First of all, we need to create a resource group, which is AZ1041BRG. So, okay. I don't know, for the reason I have this one needs to be closed. I have the other one open. So we are going to, so this is where we're at, resource group name. We'll start with the resource group name. Okay, and we have for instance, this is our DNS zone name. So you can name whatever you want. I just go to say May DNS. Okay, what? Okay. Whatever DNS zone name that you choose, make sure you know there's that name. DNS June6.com, resource group location. We're going to stay with Central US. Location, DNS name. Area Central US. Okay. I'll keep it so I know I have this information. So creating the DNS zone is pretty good. We don't have a lot of parameters. We use the same subscription. We create the new resource. Make sure you have a DNS name is unique, and we are using resource group location. I'm using Central US. Try to stay away from East US. And I am going to click create and review. Validation passed. Then we go ahead and create the DNS zone. So that's going to take us a couple of seconds. And so it came out pretty quick. So you can go to the resource if we want to. So what I want to show, in the DNS domain, we already create our DNS zone. Notice that in the DNS zone, it gives us all these values. Those are, here you can see that those are our instance names. So notice that I have AzureDNS.com and NS2 AzureDNS.net, DNS.org, DNS.info. These are all of these. We have 4 different, you can either .com, .net, but of course we use a .com, but you have all option for the same one. Okay? So we are going to open the PowerShell. I try to avoid as much as PowerShell we have to use, but as you know, we can't stay out of it. And so I'm just going to create a storage again. Okay, Thursday storage. We know that, but you guys might not have to do that, but I delete all my stuff. That's why I have to do that. Okay. So if you already have a storage, you can go straight into the portal. And the first statement that, back to the Word file here, is we're going to run identify the public IP address of your lab computer. There's a couple of ways to do it, but this is what they're making us do. This will give you your public IP address. So your IP address of your computer, the client computer we're using, that's what they're saying. That's what they want us to get an IP address. You know that there's many ways to get your IP address, right? But that's what they want us to do. We'll do that. Get our IP address. And we are using PowerShell, just want to let you know. And make sure that you have that IP address put somewhere. We will use that IP address later. We're going to use it many times. So I am going to copy that IP address. So I know that is my PC IP address. Everybody able to get an IP address, right? If you have any problem getting IP address, please let me know. This is what we need to know. Pranay, I'm not sure I pronounced your name right. Were you trying to say something to me?
Yeah, we can't see your screen actually.
Oh, all these time you didn't tell me?
It's just now, I think.
Oh, just now? Oh, okay. Okay. I don't know why it stopped sharing automatically. My apology. But you guys see that in the document, right? We are in step 2. I just run this IP address. And you guys have this file, right? Lab DNS setup. It would be very hard to do the lab without that file open. But everybody able to create the DNS zone though, right? You did the portal part done? You have to finish the first session before we can get here, right? Everybody was able to do that, create a public DNS zone. And you have your zone, right? Okay. And make sure you are in the right document. It's a lab DNS setup. So we need to set that up. We are in test 2. Step 2, I just run a IP address. And I have my IP address. You're going to copy that IP address down somewhere. We're going to need that. In this one, we are doing 2 different statements here. First, we are creating a resource group, which is get Azure resource group name, that the one we just created, and we want to get the resource group, and we're going to put it in the variable name RG. So this is for running, which we don't really have to. We can type it in as well. So back to the portal. I'm going to run that statement. All right, we have a variable RG that has stored our resource group name, which is AZ1041B-RG. It's no big deal. You can type it in if you like also. You don't have to do that. You don't have to do the RG. But when we do the variable RG now, the parameter RG dot resource group name, RG dot location. So you can use a variable that way. When you create that RG, the Azure resource group has name and the location both is stored in their RG value, a variable. So we're using it by doing RG dot resource group name. So it's going to give us the resource group. That's going to give us resource group. RG dot location is going to give us the location. Now, once you create it, I think we talked about that before. If you want to know what the value in your RG is, you can use ECHO, echo $RG. It tells you what the value in that variable is stored. Remember, see, it has two different parameter value in there, resource group name and location. So if you want to know what value in your any variable, you always do echo space the variable name. It will tell you what value is stored in that particular variable, okay? Now, we are creating a Azure public IP address. Okay? So you can see that is my IP address. Which is, as we were talking this morning, IPv4 addressing, and it is static. So I'm going to go copy that IP address again. So this is my local computer. And that's my public IP address. Okay. So far, so good, everybody? So now we're going to go back into our resource group in the portal. We'll try to do as much as possible in the portal. So on the main menu, I'm just going to click on the resource group. We only have one resource we created so far. We go into that resource group. Notice that that's our DNS zone under the type. You should only have one DNS zone. We have one DNS zone and we have one public IP address. So the DNS zone, we go into the DNS zone. So they want us to go into the DNS zone and we are going to add a record set. And we have they give us the information for that record set. This is the name of the record set. It's going to be type A, alias record. Time to live is 1 hour. I would do like 4 anyway because we want to have that for the whole session. We're adding 2 record sets here. For one, public IP, my Azure PIP, and we are creating my lab VM PIP. So we have 2 different record set we're adding, okay? So let's go in and to the DNS zone and do that. So I am in my DNS zone. Everybody able to get into your DNS zone. And on the top in the main command bar, you should see a plus record set. So we are going to click and create our first record set. So first record set, this is the name. The type is A. That's the first one, right? Yeah, that's the first one. Okay, type is A. Notice that these are different type of DNS record set. I don't want to go into so much of DNS stuff, but if you're not familiar with it, look it up to make sure you know all the different types are. Generally, we always use A, type A, and alias record set was no. Time to live, I'm just going to set it like 3 hours just to make sure we have enough time if we don't finish the 11 hour. So type A, type to live. IP address is your lab computer you identified in this test. The first one is my lab computer, the very first one. That you got that IP address that we wrote it down. That's the one we're putting in. All right, and we are ready to close this one. So we're going to click OK. So ready to populate this record set. So you should see your record set came in right away. I'm going to add the second record set here. Second record set is going to be, this is my second record, my Azure PIP. Okay, and let's see what else. Okay, this time they do want the alias record to set yes. So the second one, we need to set the alias record to yes. So as soon as you set yes, you notice that you have a option here. So Azure Resource or Zone Record Set, and we are going to use Azure Resource. And the lab subscription, of course, subscription and stuff, we're going to use the same subscription we've been using. In my case, I only have one. Resource group, we wanted to use the same resource group. Okay, so public IP address, this is all we have. We have 41B-PIP, that's the only one we have. Time to live, again, I'll make it 3 just to make sure we have enough time. If we don't finish an hour. And we're going to click OK. Everybody good, right? You know how we got the public IP there. Okay, we're going to click OK. Okay. Now we are going into test 3 in the documentation there. We're going to validate those DNS base names. So you need to, we're going to run these 2 statements. So when you do a custom DNS domain, you created in the first test of this exercise. So mine is maindns.june6.com, and the name server represent the DNS name you identify in the previous step for the name server. So the name server are here. We're going to use this name server. Okay. So let's do the NS lookup. So from the lab virtual machine, so what's from this machine, you're going to set up a command prompt. So from your desktop, we're going to do, I normally just do run CMD. We're going to run a command line. Okay, that we are going to run that, but before we can run it, we need to, so from your machine, so from your desktop machine, don't worry about lab virtual machine, you're going to start the command prompt by typing CMD, and then we're going to verify they can see this. So I am going to copy this into a notepad because we need to change stuff in here. So first, we don't need these 3s and 4s. Okay, so custom domain name, so you have to go get your domain name that we created earlier. So this is my domain name. That is our name. So I am going to go replace it here with my domain. Okay, so make sure we had it for both of them. And we're going to run these statements one at a time. Okay, and the name server is the server, so the first one, dns.com, because we did the com one. So I am going to Notepad and put my name server, replace with your name server, and everybody see where your name server is, right? In the DNS zone, you have for name server. Because we created .com, we are going to use the .com server. All right. Once I got those, we don't need the period at the end. All right, so we go, now I am going to copy this and put it in my command line. So notice that it gives you that, IP address 137.135.79.96, and so that is my IP address. So it knows. I give it a name. It knows what the IP address for that server is. So that's mean you're successful. Now I'm going to run the second one. So notice that my IP address, that was my IP address also, 40.122.73.16 for my local computer public IP address. Okay, so that means my name resolution was working, that we set up correctly. I hope everybody so far so good. If you guys got stuck, you're going to tell me, right? So we did that so far. Now we are going to, what we did, we had create a DNS zone. We had set up 2 records for the DNS zone, and we also tested to make sure that our DNS name server can translate a name, the server name, to an IP address. So far so good. All right, so we're just building stuff so we can do the application gateway to create the gateway. So we're going to do peering and all that stuff. So we're going to do a lot of fun stuff here. Okay, so back to, these are the things we're going to do. The first one, we're going to provision multi-virtual network environment. So again, we are in the Azure portal. We are setting up 2 resource group names. RG1 is what existing 401B, but we are going to create a new resource group name called 1004.2RG. Location is the same as RG1 location. You need to run that statement 3 or 4 individually. But before we run RG1 and RG2, make sure that, okay, so I am going to run RG1. So in this one, we're just, right, it has the step 3 in it, so I got to delete that 3 out of it. So we are creating a variable called RG1, and RG1 is, what's going to do is a get Azure resource group name. So in RG1, we're going to have this resource group we created in previous test. That's a value, the name of our resource group. We're storing it in a variable name called RG1. So I want to make sure it's in there. So I'm going to do echo $RG1. So, okay, so I know it working. It knows the value for RG1. The second one we are creating, the second one is we're creating a new resource group in the same location that we have for the first resource group. So we are creating the second resource group. Instead of we create the first resource group through the portal. Now we're creating through the PowerShell. So I do the same thing. Okay, RG2. Okay, not only that, I'm going to go back and do the resource group, and I'm going to refresh it. I want to make sure I see my resource group. So now we have for AZ1004.1B, and we have AZ1004.2B. So far, so good, guys. So we created 2 resource group now, so far. Now we are going to add a subnet to that 2 Azure virtual networks. All right, so we are creating a variable called subnet 1. We are creating a new Azure virtual network subnet configuration, and the name is subnet 1. It is address prefix is 10.104.0.024. But again, if this is something you're not familiar with the IP address for your organization, you need to talk to your network guy to give you IP address for subnetting. They will have IP addresses already for you, because it's already a production company for a long time. You should have set range of IP addresses already purchased. Okay. All right, so we are creating a first subnet in the, We created the first subnet. We just created the subnet. We have not associated them yet. We'll get a warning. Breaking change, whatever, that's fine. We are going to do, you get a warning, and that is perfectly okay. Subnet, oh no, is that one, subnet one? Subnet one, yeah, I think so, it's like subnet one. Okay, so value in there. Now we are going to go back here. Now we are creating a virtual network. The virtual network, in step 8, the virtual network. We're creating a new virtual network in the same resource group that resource group 1 and 2 is in. It's resource group 2, the same location, VNet 1, address prefix 10.104.0.016. All right, so that's what we're doing. We're creating our first virtual network. So we created a subnet 1, we're going to create subnet 2, and we're going to create 2 virtual networks. Subnet 1 for VNet 1, of course, and subnet 2 for the VNet 2. But when you create this in PowerShell, you notice that you have to create the subnets first before we can create the virtual network. So now we are going to create the first VNet, our first virtual network. This one to make sure. So we create the subnet 1. Okay, we have subnet 1. Now I need to create the VNet 1. So notice that when we create the VNet, in the VNet we're saying that what subnet we wanted to include it in our VNet. That's why we have to have the subnet first before we create the VNet, and we're associating this particular subnet that we created earlier in a previous statement into the VNet 1. So this subnet 1 is a part of the VNet 1 now. And we create the first networking group. All right. So if I do echo $VNet1, so it'll tell you everything you need to know in the VNet. All the stuff, your address, IP, prefix, all of the delegation, all of that. Now we're going to go in and create a subnet 2, and then we create a VNet 2. Okay, so this is all the things that we're prepping. We're almost there. So these are all the things you have to have before we can create virtual network. Application gateway heavy. You get that wording. We are okay with that. That we're going to create the VNet 2. All right. Okay, so now we have 2 virtual network 1 and 2, and each virtual network has their own subnet, one subnet underneath. Now we are going to create a private DNS zone. So here we're creating and telling what zone we are, what the name is addenda.local, the zone name, resource group name is RG2 resource group name, zone type is private, and registration virtual network ID. These are things that VNet1.id, VNet2.id, they'll read it from the record that we just created. Okay, virtual networks assigned to Azure DNS zone cannot contain any resources. Okay. All right, so we're going to create a new DNS zone. That says, but you can see there's a lot of steps we have to do to create some type of gateway. So there's a lot of work here. Okay, so pretty quick. It create this new DNS zone. So we're also going to create a bunch of stuff. So I want to go back into, is that under 4.2? Go into the resource group here. So see, we create that. This is the, so we created addenda.local. We have VNet 1 and VNet 2. So go back into that resource group 1004.2 B-RG to make sure it creates the DNS zone and 2 virtual network for us. That's what we just did. All right. So we did that in the portal. We show you how to create DNS zone. We also show you how to do that in a PowerShell here as well. Now, then we go to get DNS zone resource group name. Verify the private DNS zone was successfully created. Well, we know it's created because we saw it. But we want to double check. We'll double check here. Okay, so we know it has created both of them. Now, the next thing we're going to do is we need to deploy that VMs that we created earlier into the virtual network. Right now, VM is separate, virtual network is out there, but the VM has no virtual network attached to it. So we're going to go in and create those. So, okay, here we need to upload these 2 files into the Cloud Shell, okay? So that's something new. So I want to make sure if you guys want to look at, if you're doing, if you're working with me on this and you're doing the lab also, look at my screen just for a second. You notice that next to, in the PowerShell command line, next to that little gear, there is a upload download file button. Do you see that? It's the 4th one from the right. And it's also the 4th one from the left as well. Everybody see that upload download files one? If you see the upload, so we're going to click on upload, click that arrow. We're going to click upload. We got to go get that file that earlier I said that you guys had to make sure you have those lab files. That's what we're talking here. So we have to make sure that it is AZ10004B-01. So these are very similar files out there, guys. So we've got to make sure it's AZ100. Okay, so the left file 104. So 104B. Make sure there's a B in there. 104B. Azure deploy, and you have to bring that one at a time. We are bringing 3 files up. Azure 10004B01. I'm uploading that file. You can only upload one at a time. Then I am going to upload the second file, 10004B-02. Okay. Then the third file I am going to upload is the 104 with no B. It's AZ10004 Azure deploy.parameter file. Everybody got those 3 files? You guys good? Okay, guys, we got to make sure you load that 3 files before we can run the next statement, which is here. Because it is using these files. It needs to know where those files are. If you have the files uploaded, then we go to step 2. We are going to create a new Azure Resource Group deployment. Now we need to deploy those because we create them, but we have not deployed them yet. So everybody able to deploy? I'm assuming as long as I don't hear anything, you guys are doing okay. But if you're not, feel free to stop me, please. Do not. We need to make sure you can create these because you cannot deploy it. It's not going to, because we need to use these for the future, the next labs that we do as well. So I need to make sure you guys do able to do this successfully. Okay. All right. States are not started. States are not started yet. So. Okay, so it takes a couple of minutes, but when I run the get job, it should be, I can see both of them are running. So far so good, guys. We are getting there. We're almost at the end. So we are going to the next thing we're going to do. We're going to validate that DNS-based name reservation and resolution for the private domain, because we did it for the public domain. Okay, so now we need to go back into the 42B VM2, and in that blade, we're going to RDP it into the virtual machine, which we've been doing this many times successfully. When we are in that VM2 machine, we are going to run this. That's what we're going to do. So let's go back to the portal, and I am going to scroll this one down here. So notice that we want a virtual machine. So if I scroll down, I should see, you should see your VM1, and they want us to go to VM2. So VM1, I see my 42B VM2. I'm going into my virtual machine because we need to connect to that virtual machine. Make sure we are in the 42B-VM2 virtual machine. We click on connect. We download, click the connect and download. We are going to connect. Okay, the username. Okay, so the username is, it should be the student and this. Okay, now I am in my VM2 virtual machine. So once you are in the virtual machine, after you're able to connect to the virtual machine, we are going to run the command line again. So I just click run, CMD. Then I need to go get the NS lookup file, NS lookup command. So I am going to okay, so give me the address. I'm going to copy that. So that means that it can resolve the name. So that's good. Okay, that's the VM2. Okay, and now we are going back to the portal, and then we are going to add additional record set. So that's what we're going to do in the portal. So we'll switch back to the portal, and we're going to run that statement, adding a record set to that DNS we just created. And once that is done, we'll go back to our remote VM machine, and we wanted to do what is the addendum.local is. All right, so it's going to give you that IP address here again. I just copied the IP addresses I like just to make sure to have that. All right, so that's what, once we done, that name is successfully resolved. So what we did, you have provisioned a multi-virtual network environment. We created a private DNS zone, which is, we create the DNS zone. Remember, you create a custom DNS zone, as well as we create that addendum.local. We also deploy Azure VM. We create Azure VMs, and we deploy it into the network. So now the VMs are associated with that network. And also we had validate that DNS-based name reservation and resolution. So if we connect it with a name, it knows the IP address. And we've confirmed that that is working for both a public and private domain. So that's what we've done so far. Any questions, concerns, burning desires? Nope. Okay. The next thing we're going to do is we are going to do the second statement one, which is, I'm going to tell you exactly which file it is. It is we're going to do the lab of the VNet peering. We have to do one at a time, but that's the next one we're going to do. Let's go into VNet peering. Okay, let's get into do the VNet peering. I can't remember the lady that was interested in the VNet peering and stuff, and hopefully she's in a class today, right? All right, I'll be right back. All right, I am back. I am so sorry. This morning I'm having a sick stomach. I don't know what's wrong with me. But all right, so we are going to do the VNet peering. So that's some pretty cool stuff that we're going to do. So VNet peering is that if you have in your organization, like I said, we're going to have multiple VNet. So you're doing a peering. So if you have from one VNet that, within that VNet, virtual network, let's say you have 5 servers, and in the second VNet you have 10 servers. If those virtual machines from the second VNet or vice versa, or the first VNet, if they want to communicate through, communicate each other from, from a different, on a different network, but they are in the same, same organization. That's what we call that VNet peering. That's what we're going to do. That's what a peering will allow you to do. So connect from one side of one service on the one VNet to the other VNet, or the other VMs in the other VNet. So we have to have two VNet. That's what we were creating all these up front when we're doing the DNS stuff here. All right, we are going to create the first virtual network hosting to Azure VMs by using an Azure Resource Manager template. So now we're going to create these again. All right, so we are going to go back into the portal. From the portal, we are doing that. So DNS setup is done. I'm going to close that one out. Go back to my portal. All right, go back into the portal. From a create a resource, we're going to select template. We've done that the other day too. We've done the template, and in the new blade, when you type in template, it shows up template deployment. You're going to select the template deployment, and we are going to click create once we are in the template deployment. And when we click create, we'll be in here. We are going to select the edit template, which is a little pencil icon, and we are going to go load we're going to bring in a file. So here we're not teaching you how to write JSON files, we're just giving you the JSON file, but that's something that you'll need to learn how to do that if you wanted to pursue using the template in here. But all these JSON files that you can find on Microsoft site, on the GitHub, there's a bunch of samples out there. Normally just go get the sample and modify it to what your needs are. That's what we normally do. So I'm going to click on the load file, and they want us to load AZ100-0402 Azure deploy.json 0402. So I'm going to click open. I'm going to save that file back in the template. Now this time we're going to edit parameter. Select the edit parameter. Once you're back in the template, in the edit parameter, we're going to load again. This time, we are loading the parameter file. So we are loading AZ100-04 deploy, Azure deploy dot parameters. So I'll bring that file in. I'm going to save. Now we are back in the form that we're going to change stuff in here. We're going to leave of course, we only have one subscription, at least I only have one, so I said that. We are going to create a new resource group. We're going to create a new resource group. So make sure that I don't miss that. I will go copy from here. One second here. Why is it say resource group 402 RG? Hold on a second. Did I bypass something? No. This is the first one we created. 40401. 400 401 RG. Okay. Okay, so we created two times. Okay, got it. The first one is the 04. We are creating the 0401 RG. Do we have that resource group already? Let me see. Back in the portal. Cancel it for a second. I just want to see. Oh, we have the B. We don't have the 01. Okay, so this is for this one. We are creating a different resource group, 41RG. We have the 41B and 42B, but not just 41. This one just 41RG. Okay, Central US. We're creating in the same place. Notice that it is creating a VM name. Okay, so VM name, we wanted to make sure 401 VM3. We are creating a 401. Hold on 1 second. I don't know why we have documentation is saying 4.2. Did I miss something here? Hold on, maybe I didn't print it right here. Okay, so we have to create both of them. We have to create 4.1 RG and 4.02 RG. For some reason, I don't have 4.2 RG. Okay, so 4.1 and 4.2, so we had to create two different resource group. And under the 4.01 RG, we have two VM name. Okay, so VM1 and VM2. Okay, I just wanted to make sure. Okay, so we are in the 4.01 RG, and we need to have two. See, it's not letting me have two different VM names though. Okay, let me back up here. I think I had bring in the wrong file. Let me go back here. So let's go back here. So we are here. We need to bring in 0401. I don't think I brought in 0401. I brought the 0402. Okay, well, this one, I know this one is for the second one, so I'm going to do this one first. I may use the 402 first, and then I'll go back and do 401. Sorry, I don't know why the documentation I print out didn't have that. And the 402, the M3, that leave it the way it is. And so student on that, this is the 402. I create the 402 first instead of 401. I need to make sure this is 402 RG. Okay. And make sure the VM name is 402 VM3. We have that. It's a 402 VNet2. Okay, so that looks good. And I purchase. Go ahead and create. So I create the VNet, the 402 first. Then I delete everything, so I don't have the dashboard anymore. I don't even have a summer dashboard. Yes, I do. All right, so when that's creating, we can go in and create the second one. In this case, will be the first. Create another one. We have to create two. We're going to use the deployment twice. So we're going to create. Go into edit template. Load the file. This one, we have to load 0401. Azure 0401, okay, 100 0401. So we are going to do 100 0401 Azure deploy. Okay, save. Edit template. We're going to load 040 Azure deploy parameter. We only have 041 of them for Azure deployment. 0401, and then we do the 04 Azure deploy parameter. The step was correct, so just follow the step. I screwed up a little bit, I'm sorry. But we did the same thing. I just did it backward. I did the 041 first, 42 first, and I'm doing 41 now. And the documentation is doing the 41 first. That's the only difference. All right, we can create a new resource group. So the new resource group here is the 401 RG. So earlier we created a 402, now we have a 401. Okay, notice this one has two, which they are asking us to create. Make sure there are 401 VM1 and 401 VM2, which is we have that for VM1, VM2. This is correct. We need to make sure the VNet The virtual network name is what we want, 401 VNet 1. So let's go to 401 VNet 1. We are good here. We are going to agree and click purchase. And so we have create to deployment. So both deployment is running. It's not done yet. Now we are going to create a second virtual network. So we want to show that from one VNet, you can connect to the other VNet, vice versa from VNet 1 to VNet 2 in the same region and also from different regions. So that's what we're going to show. Once those come back, we are going to create more Azure VM stuff. So, all right, so we had create 401 and we have create 402. So now we can start, once the V1, 401, 402 come back, the deployment is complete, we are going to do VNet peering. So make sure, let's wait for that to come back. Okay, so 1 come back already, 402 came back, because I did the 401 backward of 401, 402. Everybody, is that making sense though, what we're trying to do? I just want to make sure it makes sense what we're doing. So we created 2 different virtual networks and we're going to peer those so they can, everything in VNet 1, all the associated VM to that VNet 1, all the associated resources in VNet 1 can connect to all the resources in VNet 2 because we have 2 different networking. That's all we're doing. Does that make sense? So with that, we'll do the peering, and after we finish the peering, we'll go for a lunch. We'll go for a break. So we'll be ready for a break by then. Okay, once we're waiting for that, I don't know about your stuff come back yet, but my 402 is back, so I can go into 402 to do the peering. So that's what I'll do. So instead of waiting. Okay, so I'm going into the 402 because that's the one I created first. So if you create 401, then you have to wait. My 401's not back yet. So once I'm in the 402, oh, mine came back. Both of them come back. Yay. Okay, so in that case, I'll go to the 401 resource group. Well, we wanted to go to the virtual network. So I am going from the main menu. I'm going into virtual network because it's easier to see my virtual network. So notice that we have 401 VNet 1, 402 VNet 1, 2 for B, and 402B, 402B VNet 2, and also have 402 VNet 2. All right, I don't know why I have many of them, but all right, so we need to go to 401 VNet 1. In the 401 VNet 1, I am going into, when you're in the 401 VNet 1 virtual network overview blade, notice that we have 2 NIC cards here, NIC 1 and 2, subnet 0 and subnet 1. These came from the template we created. So under the settings, you should see peering. So we're going to click on peering blade. We're going to add a new peering. So we're going to click on plus add. So it's going to ask for the name for the peering. So for the name of the peering is here. So we're going for a 401 VNet 1 to 402 VNet 2. So we are going to say, hey, that's where we're going. We are going to leave it as a resource manager for the for the peer detail, you have Resource Manager in Classic. We're going to choose Resource Manager. In subscription, we are using the same subscription you have always. Virtual network, we are going to do, we wanted to connect to VNet 2. So we want to go to 1,402 VNet 2. Okay, hold on here. 1,402 VNet 2. So we are going to that. You have to click on the drop down. That's all we need to do. Quit this for a second. VNet 2 configuration. We are enable is correct. Allow forward traffic is disabled. The rest, I'll leave it the default. And we're going to click OK. Okay, and so notice that it's initiated. We start appearing. We are going into in the virtual network. Well, in the next one, test 2, we are going to 1,042 VNet 2. Doing the same thing under the settings, under peering. We got to go up. So we have to add from both of them, right? From one virtual to the other. So for both virtual VNet 1 and VNet 2, we have to have a peering. So peering is going both ways. Okay. So here we are going into, we are in test 2. So we are going from 402, we are in 402 now, that we want to go to VNet 1 in 401. So that's what we're doing. So the name kind of apply what we're doing so we don't have to look at it. Under the virtual network drop down, we wanted to make sure you select 401 VNet 1. Make sure it's enabled. Leave the rest at default. We are going to click OK. All right. So we have both peering. However, we still have to add a routing, custom routing, because the routing is going to tell us where to go. So now we go into the routing session here. So we have to create this VNet peering on both. Now the both VNet peering is going to go through a routing. So now we have to implement a custom routing. We got to make sure we have IP forwarding for the VMs. So we'll go back into 401 VM2. We're going to the VM this time, not the networking. We are not the virtual network. We're going to the VM itself. So, and test 1. So we go back into the portal. I'm going to select on the main menu, I'm going to select virtual machines so I can see my virtual machines I have. I am going into 401 VM2. So 401 VM2. And there I am going into the networking blade, which is under the settings. Okay, in the settings. Now we should see AC401 VM2. That's where we're in. We are seeing that NIC2, 401 NIC2 in the network interface card. We are going to click that. And then we are going to display the IP configuration blade, which is under the settings. You got to make sure we are in the NIC card, though. We are in the network interface card, 1041 NIC2. Under the settings, we are going into IP configuration. Now we're going to the IP configuration blade. We are going to enable IP forwarding. Notice that IP forwarding is disabled. We are going to enable that IP forwarding. And we are going to click Save. I want you guys to be able to read this part also. It's saying that AC 1041 VM2, This is our NIC card, which network interface card, the NIC card in this test is configured as a router. It's going to work that as a router, facilitating service chaining between the two virtual network. Okay, so we are going into configure user-defined routing. Go into the resource plate, going to go create, type in route table. So here, go to create a resource. I'm going to select route table. I'm in the route table. I'm going to click create on the route table. And the name of the route table is 1401 RT1, route table 1. Use the same subscription. Resource group, they want us to use 1402 RG. All right, then virtual network gateway route propagation is disabled, and we are going to click create. Okay, click create. All right, I'm going to wait for that route to table to come back. So I'm going to go look and keep the all resources open. So as soon as this come back, we will know, we'll find our router table. Okay, deployment succeeded already. Believed. Okay, so now we are going into, let me go back to that. I got too many of them. They're back. Yep. Okay. I'm going to dismiss all so I don't have a full screen here. All right, then I'm going to go into our route table. So I select on all resources so I can see my route table. So I'm looking down here. Okay, and the type, I'll see my route table, 402 RT1. We only have one route table right now anyway. So I'm going into the route table. At step 7 in the route table, I am going to add in the route table, you are going to select the route. And we are going to click add the route name. So we are here, that this is the route name, IP address, address prefixed. Again, these are given to us, but in your environment, these address prefix may not work. Okay, it might not work. Okay. And next hop type, we're going to say it is virtual appliance. And then we have to also give the next hop IP address. So when you're going through a network, it goes from one to the next endpoint, and we need to know that we need to make sure that that's what we call next hop. So we have to make sure the route is okay. So now we are going to add the route. So, okay, so we're going to click OK. So let's also notice that what we see here is 104, the 104.1.4 is the IP address of network interface of the 401 VM2. This is the second VM, which will provide service chaining between the two virtual network. Okay, now we're going to need to add subnet. Then as you can see, this is a lot of stuff we had to do here, but once you do it all the time, it's not that bad. Okay, sorry. We need to be in the subnet under we are back in the 42 RT1 route. We had create a route, and now we have to go add a subnet, which is under the settings. So under the settings, I'm going to select subnet. And we go to click associate. We have to associate. So in the virtual network, associate. (1402) VNet 2. Okay, 1004.402. Is that right? 1004.2 VNet 2. And we are connecting with subnet 0.42.42.RG. This should be VNet 2, though. I don't know if I must have screwed up something here. If I don't, I'm thinking RG subnet 0. Net 2. Okay, that's fine. Adding a route here. Okay, so we have a subnet. Okay, it is VNet 2. Now, okay, so we're good here. Now we are going to configure, task 3 is we are going to configure routing in an Azure VM running Windows Server 2016. So we are in test 3. So now we go back to 401 VM2. We're going back to Azure VM. So going to the VM, I'm going to open the virtual machines. I'm going into 401 VM2. Connect to the 401 VM2. All right, I am going to open that, make sure I can connect. Like always give us username and password here. Okay, then I go get the password. So yeah, this part is a little tricky, and as I say, these are things that you normally have to do it only one time. You will not never have to do that again. But it's good to know that the steps that, what are the steps I have to go through to create a router, because I don't think most of you guys may not have a permission to create, these type of stuff in your organization. All right. But you can kind of have a appreciation on how hard it is that you have to do to create all these. We're almost done. We're almost there. We are almost there. You have to go in Open Server Manager. This will take a little bit, couple minutes, but wait for it. It will show it will come up the Server Manager. So we are in step 4, task 3 of step 4. I don't know if any of you guys are following me or just watching me doing it. Either way, it's okay. I'm waiting for Server Manager to come up. Yeah, there we go. Okay. So once you get into the Server Manager, step 4, they want us to add roles and feature wizard. So go into add roles and feature wizard. Collect inventory to be available after data collection finish. Okay, it's still not ready for me yet. That's all they're saying. Okay. Wait till they got all the, yeah. Okay, so we're going to select the Add Rules and Features. So when you're in the Rules and Features, we're going into rule-based, feature-based installation. All right, we can see that a virtual server pool. We don't have any of those. Now we have to add the rules here. Next, previous, like remote access checkbox again. Okay. And add the remote access server role. So this is where I have to come in and add. You see that there's a remote access, remote desktop. So make sure we collect the remote access server role. That's all they want us to make sure we have remote access server role. Right, go away. And here, server role in the routing role. So we got to make sure we add the routing in there. Add features. That I add everything I wanted to. And that's about all we need to add is a routing role with a routing role service all required features. All right, I think we're good here. Mm-hmm. So we have to install some stuff here. Everything takes time, huh? Almost there. That's what I've been telling you, right? We're almost there. A couple more minutes, you should finish. It doesn't take that long. And hopefully this gives you guys at least some background on how these routing things works and all that. So after this one, that's when we're going to create application gateway. We have to have all of these before we can create the application gateway. So we are going to go for a break, and when we come back, we'll do the application gateway. Create the application gateway. Routing and remote access there. Okay, that's going to bring up the routing and remote access configuration wizard. I don't know why this is still in red, but maybe it's still we're doing something here, but okay. In the remote access, custom configuration. Wizard. And custom configuration option. Routing and remote access. Okay, now we are in the routing and remote access server setup wizard. So you guys see that, right? Went into the action and click on the remote access server. In here, we need to make sure we have select custom configuration And in the custom configuration, we need to set up LAN routing, local area network routing, and start remote routing and remote access service. LAN routing. Server we have. I can choose LAN routing. And okay. Yep, LAN routing. That's all I see there. Okay, LAN routing. And finish. Okay, so we're going to start the service. Okay, so you see there's a bunch of stuff comes in. Windows Firewall, then we got to go into Windows Firewall with Advanced Security. That's step 7. Then we have to go in and make sure we enable file and printer sharing, inbound rule. So go into the inbound rule, and then we need to go find file and printer sharing. So we go in here, file and printer sharing. Echo request ICPME4. It's hard to see that ICP request. There is 6 and 4, so we got to make sure we select 4. We are going to enable that rule. Okay. Now we are good, and now we need to go check the validation service chaining. So we got all that. Now we are back into the portal, thank God. Back to the portal. Back to the portal. Now we go back to VM1 virtual machine, for one VM1 virtual machine. From that, for one VM1 virtual machine blade, we are going to connect to for one VM1. Same thing, we are using the same username password here, but we are now here in service chaining. So we're in service chaining, doing the same username and password. And we are here. Username, paste. We could get the password. We have to enable on both VM1 and VM2. So that's what we have to do. We have to go to firewall and do that. So that's why we need to connect to VM1, because we did it in VM2. So you know the drill. That takes a couple minutes to do that. All right, so we have to go back into Windows Firewall with Advanced Security Console, and then I have to turn on the file and print sharing inbound rule. So you have to set up inbound rule for both VM1 and VM2. So that's what we need to do. Okay, go back to the inbound rule. My machine is running slow today. Then go back and look for that file and printer sharing. Make sure we're turning on the IPv4 and enable the rule. Then we are good here. Okay, when that's done, that is done. Enable. I am going to go logged out of that one, disconnected from that one. Then we are at the last one. We are testing our service chaining. It better work. If not, I'm going to shoot myself here. We'll go to 402 VM3 VM. So go back to the 402 VM3. All right, we have to RDP again. All right, we're going to open. Oh, come on. We don't have all day. All right. We have student. All right. Yeah, good. So when we're in here, we're going into Windows PowerShell, and we're going to run that connection, testnet connection, and we're giving a computer name, we're giving an IP address, and you should see that it routed through the 10.104.04 is the VM1 addressing. So what that tells you that it is routing it through VM1 is what we're trying to prove to you. Even though we are connecting to the 402, it is going to route through the 401 because that's how we set up in the route table. That's all we're trying to prove to you. not me though, right? Oh, not that one. We want to do the other one. We want to do the gateway one. We want to create application gateway. So let's open up the application gateway with web application firewall using the Azure portal. So this is the thing that we've been trying to build up to create the application gateway. We're going to create application gateway with the WAF enable, which is web application firewall enable. We're going to create virtual machine to use as a backend server, storage account. We are going and configure diagnostics, and we are going to test our application gateway. And yes, I have not shared my desktop yet, but everybody able to open that file? Everybody have the file, right? It's in Skype that I have uploaded, so make sure you guys have it. So that's what we're going to do. We are going to create an application gateway with web application firewall enabled. We're going to create virtual machines for backend servers, as well as we're going to create a storage account, and we're going to add configured diagnostics to it, and we're going to test the application gateway. So that's what we're trying to do. That's what we've been building to do today. All right, so if you're looking at also here, just want to get the idea. So this is your WAF, which is web application firewall that we're using a built-in one. So you have to have your own public IP address that goes through your gateway, and it goes into the backend pool. So this is somewhere here is going to get a request. Clients are going to request. It's going to go through that firewall first, and then it's going to go through your application gateway. So we're having, again, two sets of doors. So hey, make sure that you are, your web application firewall rules, you are approved. Then in the gateway, we are also adding an additional level of security for our application, and then they get approved from this application gateway. Say, yes, we identified you, we authenticate you, your identity is good. Then they go into the backend pool in your application gateway. So that's the model we're doing. That's a model that we're going to be implementing. So we are going to sign into the Azure portal like we've done before. We're going and create application gateway. So let's go into the portal, back into the portal. We are going to create a resource. We're in the new blade. You are going to select, once we're in the new blade, we are going to select networking, and select networking. We should see application gateway in the feature list. We are going to select the application gateway. All right, now we are in the basic page of application gateway. It's asking for the name of your application gateway. Where's my document went? All right, and there we are going to, that is my app gateway. That's what we are going to create. The tier is important here. Where is our tier? We need to make sure the tier is matched. Okay, we'll come back to that. Don't see the tier yet. My app gateway resources group. We call it tier. Okay. I don't think the tier was, I thought WAF turned on. All right. Okay, yeah, select the for tier. Yep, WAF gateway has to be that. SKU size, we leave medium as your pass. We leave we are going to create a new resource group called My Resource. For application gateway, My Resource Group gateway. Location, we just leave it for Central US. Yeah, your virtual network and public IP address must be the same. Yeah, I think everything I choose for Central US. So we got the application name. We have the tier. Notice that there are different type of tier. And we use WAF. We are SKU Size, subscription, resource group, my resource group AG, location, Central US, and we are clicking OK. Okay, and that's now we are in the settings section. In the setting page, subnet configuration. We're going to select subnet configuration and choose a virtual network. We are going to select create new, and we are setting the name is my VNet. It would be good. My VNet address range 10.00.16. We're good. The default, the subname is my AG subnet. So I am going to create my AG subnet. Okay, and subnet address range 10.00.24 for the subnet address range. So that looks good for the setting. 10.10.16, the space, subnet is 24. Good. Now that we are in the forward IP configuration, we need to, front end IP configuration. We need to make sure that public IP address type is public. Under public IP address, verify is create new, and this is the name of IP address. Okay, and enter my public IP address. We're going to scroll down here. Front end, public IP address. Okay, the name. So that's there. Good. We don't add anything else. They didn't tell us here. Okay, so we have front end IP public, create new. We have this. We have our listener configuration. They didn't tell us anything to change there. Good. I think that's all we need. All right, and now I'm going to click OK. So that's our configuration for my app gateway. Do one thing here. I want to make sure we have a screenshot of that to make sure I know the configuration there. Click OK. All right. So once that is deploying, okay, deployment in progress. A lot of rush and wait is what we're doing. Okay, so when this comes back, what we got to do is we go to create a backend pool. So it's pretty, and we have to create another virtual machine. And we're going to add the backend server to the backend pool. we need to create a storage account. So we got about good 30, 45 minutes to do stuff here. Okay, so we're waiting for that to come back. In the meantime, let's go create a 2 virtual machine. That is going to be. So we'll wait for that to come back. In the meantime, I'm going to bypass the step and go to the create a virtual machine step. And we've done these before. So we've been doing this before. Windows Server. So Windows Server 2018. They want us to use Windows Server 2016 Data Center. I don't know why I always have a problem finding that. Okay, go back to that's from here. So 2016 Data Center, just choose it from there. We want us to create Windows Server 2016. Okay, resource group. My resource group AG, which we already created. My resource group AG for application gateway. The virtual machine name is my VM. We wanted to ensure it's in Central US. Make sure everything is the same place. Azure username and password. Okay, they want to use Azure user. Azure user. Password is, and I am reading it from, I'm picking up the documentation from here instead of the basic page, which we did in my resource group AG. We already done that. Now we finished this one. So we are creating a virtual machine now is what we're doing. Okay, create an application gateway. And that is what we're doing. We're going to add, we'll bypass that for a second because our VM is not back yet. So this is where I'm going in. I'm going to create a virtual machine. And here we need to create 2 different virtual machines here. So this is where I'm at, just to make sure you guys know where I'm at. And this is what the password we need to use for that user, okay? So this is where we're at. Go back to the portal. So password, okay? And we are going into, the next thing is we're going into the disk. Under the disk, we need to make sure this and select, okay, we're going to leave the default there. We go into networking tab. In the networking tab, virtual network, subnet is my backend subnet. Okay, all right, so that's what I couldn't do because we don't have a backend subnet yet. Okay, never mind. I can't create that yet. I have to wait this to come back. I was hoping that we can bypass a step, but we can't. All right, never mind. Man, today's a hurry up and wait kind of situation, okay? So hang in there. We're almost there. I had to add a subnet quick. Without the subnet, it's not working, so we can't create the VMs. All right, we got about 30 more minutes work to do, so we're still, time-wise, we're doing okay. It is creating a bunch of stuff, guys. So that's why, okay, WebDots, we are waiting for that. It seemed like it's taking a lot longer than I wanted to. I want you guys also know that if you're looking at the, okay, so hopefully they'll continue running. Notice that I put a bunch of extra stuff in the extra folder for you guys, because these are also a good one. I know we don't have enough time to do all of that. Create application gateway. I'm trying to see if I can make this thing bigger. This column to be bigger. Okay. All right. Anyway, it doesn't. We have so there is 5 more tutorials that if you guys can do it, you want to do it on your own. I just want to make sure you have the information. Creating auto scaling, create application gateway with URL path, application gateway with URL path-based redirection routing, create an application gateway that hosts multiple websites, connect a computer to an Azure virtual network using point to site. So these are all good ones to do as well. So hopefully you guys go to take advantage to do some of those. All right. Let me go back to my VIA. Still deploying. Okay. If that's still deploying, let's go back to our PowerPoint. So we went and did the first one. There is several that we're doing. We already did the VNet peering, but let's go back in and talk about that. About the VNet peering that we did. We didn't have made it to the express route here, but everybody got that. What we're doing in the VNet peering is connecting to Azure Virtual Network, VNet 1 and VNet 2. There's 2 types of peering we have. We have 2 types of peering. We have global VNet peering and regional VNet peering. Regional means that both VNets are in the same region. So that's what we call the regional VNet peering. But if you go out to, this is region 2 is South Central US, region 1 is East US. If you're peering from a region 1 from region 2 into region 1, that is global VNet peering. And so that's what we did. And from VNet 2, it has a forwarding to the VNet 3. That's what we created. VNet peering connects to Azure Virtual Network, no transcend, 2 types of peering, regional and global. Notice that when you're doing peering, you don't need any gateway or anything. Peered network use the Azure backbone for privacy and isolation. Easy to set up, seamless data transfer, and great performance. And we did the VNet peering. You can allow forward traffic, gateway transit, use remote gateways. So these are all the things that you can do when we're creating the VNet peering. So you have 3 different options. And we did the forwarding. And gateway transit allows peer virtual network to share the gateway and get access to the resources. You do not need to deploy a VPN gateway if you're doing this. VNet peering. Global VNet peering that you can do between the same or 2 outside. Notice that when we do the peering, it shows the status initiated. Virtual network across the region, status can be initiated or connected. Special requirements. Public clouds only. You cannot do VNet peering on private cloud. Virtual network resource limitations. No gateway transit, no transitivity, and limitations on high-performance virtual machine. So some gaming virtual machines are really, really big and really, really high powerful. If you need those gaming machines, we cannot use. You cannot use peering, okay? And we did that service chaining is what we just did. Leverage the user-defined routes and service chaining to implement custom routing. That's what we just did. Implement a VNet hub with a network virtual appliance on a VPN gateway. That's what we did. We did a hub and we selected a virtual appliance. Service chaining enables you to direct traffic from one virtual network to a virtual appliance or virtual network gateway or a peered virtual network through the user-defined routes. And that's what we did. VNet to VNet connections, what we do, you can implement VNet to VNet connection. You can create a gateway subnet. You can create a VPN gateway, VPN type, gateway SKUs, create the local network gateway. We can configure the on-prem VPN device. We can create VPN connection, verify the connection. So VNet to VNet connection. So here's your VNet 1 and VNet 2. This one, for security reason, they are going through a gateway connection, and then they go through the IPsec tunneling to make that for encryption, and then we go through another gateway before we can go to VNet 2. So normally the gateway is talking to the other gateway. If you're going to do that, you have to make sure you have gateway on both sides. Okay, that's VNet to VNet. When you're doing site to site, you are using that, again, you're using the tunnel VPN, but it is going through to VPN VIP networking. So we're not, it doesn't have to have gate to the other gate. You don't have a gateway connection. Implement VNet to VNet connection. We create a VNet and subnet, specify the DNS server. That's what we did. And now we're going to create a gateway subnet and create the VPN gateway. And that's in Azure. And in the on-prem, we're going to create, on-prem we have a local network gateway, configure the VPN device, and on the Azure, you're going to create the VPN connection to connect to that VPN device. So it takes time to carefully plan your network configuration. The on-prem part is necessary only if you're configuring site to site. Always verify and test your connections, of course we will. Now we're going to create a gateway subnet, contains the IP address to use the block of /28 or 27. You can create your gateway subnet. Gateway VMs are deployed to the gateway subnet, and we're going to configure that with the required VPN gateway setting. Never deploy other resources, for example, additional VMs to the gateway subnet. We're going to avoid associating network security group with the gateway subnet because we don't want security group to block us. Creating the VPN gateway. Use the VPN gateway type. Here's one we're saying gateway type, either VPN or express route. We're using a VPN. Most VPN types are route-based, not policy-based. Your choice of gateway affects the number of tunnels you can have, and the higher tunnels you have, the more expensive it is. Associate a virtual network that includes the gateway subnet. It takes about 45 minutes to provision the VPN gateway. That's why we didn't do that. VPN type, again, we have route-based and policy-based. So route-based VPN use routes in the IP forwarding or routing table. Policy-based VPNs encrypt and direct package through IPsec tunnels. It's an encryption thing on the IPsec policy. So if you have if you're sensitive data for a security reason, you want to do policy-based instead of route-based. More secure. And this is talking about the VNet tunnels, what maximum throughputs are, maximum machines you can have, and what is supported or not. So again, that may not be the latest key. You might want to look at Microsoft Azure site to make sure. So refer to the on-premises location. Give the site a name by Azure. Create a local network gateway. The local gateway needs a public IP. Specify that prefix. They'll be routed through the gateway to the VPN device. Then we're going to configure the on-premise VPN device. This is your on-premise network VPN. We're going through IPsec to a gateway. Go to our application gateway. Go through to get to your virtual network. So there's a lot of work going into that, right? Create the VPN connection. But once it's working, you only have to set up one. So it's not like you're setting up every single time. And you can test to make sure that you can create the connection between them. VNets are the same. They have to be in the same subscription. And the share keys go to provide the connection for us. You must create connection for each virtual network. If you have 5 virtual networks, you should have 5 connection key. And verify the VPN connection through the Azure PowerShell, or you can PowerShell. You can use the Azure portal. Then the next one, Express Route. So there's two things. You have VPN gateway, or you can use Express Route. So Express Route is more. You normally use Express Route if you have a larger system. And because when you do express route, there's a lot more cost involved as well. Because in express route, you are using a Microsoft Edge, so that is additional server, additional service. And the partner, which is the on-prem, also you need to have an edge. So pretty much the partner edge is what the on-premises edge is going through. So instead of the gateway, you're going through the edge. And you notice your primary connection, secondary connection, you can have as many connections you can handle is talking to this edge before you can go out to talk to anything here. So extend on-prem network into cloud with a dedicated private connection, and not every region has it. You have to find out which region carries it. You also have to make sure that, because we are using private connection, that means that you have to have a private network. You need to ask your carrier to make sure they can assist you with that. They can provide that. If that is going through the, a Comcast or AT&T, whatever you use, it's going through their network, going through their wire. So route capabilities, it is doing a layer 3, connectivity with redundancy, connectivity to all regions within a geographical location, global connectivity with express route, premium add-on across on-prem, connectivity with express route, global reach. Bandwidth options is from 50 megabyte per second to 10 gigabyte per second. Billing models is unlimited, metered, and premium. So here you can see that Cloud Exchange co-location with using express route, point-to-point Ethernet connection, or any-to-any connection. But express route is a little more expensive, and make sure that it's only doing one-to-one. So if you have in a coexisting site-to-site and express route, so notice that express route is not going through any tunnel. So site-to-site, it's going through a tunneling. So it's a two different way of you need to design which one you like better. Site-to-site VPN is a secure failover path for express route. So if you set up express route, it's faster. But just in case, if the express route network goes down, the site-to-site will become a failover. So when we're setting up these failover and availability, not only the machines, we also have to set up availability for the machines as well, right? For the networks as well, because the machines may go down. You got machine 1 goes down, machine 2 kick in. But what happened? What the virtual network goes down? So in this case, if VNet goes down, VNet 1 goes down, then it's going to switch to site-to-site connection, and that is your failover from your express route. But express route is the fastest. All right, and we did the peering thing. We are trying to do this application gateway lab right now, and as we have SSL, we'll see if we have time to do that. The next thing that we'll do is that load balancer traffic manager. I just put that in because I know some of you guys are interested in that, and I give you the demo and everything, so you should be able to do that. So let's continue back to our create a new subnet. So these are completed. So back to our documentation here. So I will try to jump it, but it won't let me because we need to create a back-end pool here. We're going to create a new subnet in which the new VMs will be created. So we had to create a new subnet called My Backend Subnet. And we're going to create two new VM, My VM 2, to use as the backend server. We're not really going to install as a virtual machine. It was created successfully. Back the backend server to the backend pool. All right, so let's go into create a subnet. So we are going into here from Azure Create. We're going to create subnet. Sorry, I had stuff in there already. Oh, that's not a separate resource. Okay, so we have to go to your VNet first to create a subnet. So we go open our virtual machine we created. So, and virtual machines. Virtual network is what they're saying. Sorry, virtual network. So we just create that my VNet. We need to go into that my VNet. In the my VNet, the ones we just created. So I just went into the virtual network and select my VNet. We see my app gateway. For that, we are going to add subnet here. So we are going to click and select subnet. And we are going to add a subnet. Okay, and as our subnet is going to be my back end subnet. So getting a back end subnet. Address range, we didn't tell us anything, so just leave that.
22439254999.
Was it somebody's phone? Okay, definitely not mine, so. Okay, so at the subnet page, enter my backend subnet for the subnet and then select OK. So we're going to leave everything default. We just had to create my backend subnet and we're going to say OK. And now we need to create the two virtual machines. We had to make sure the subnet was in. Okay, subnet is done. Now we're going to go and create a virtual machine. So go back to create a resource. So we're going to create Windows Server 2016. We're going to use the same one, the My Resource Group AG, virtual machine, my VM. He wants my VM and my VM 2. Make sure this is Central US. Okay, that's for the username, Azure user. Password, Azure 123456. All right, public inbound rules, they didn't say anything about it. They want us to go to the disk, that default, we go to networking. Okay, and then here's where we need to make sure it has the subnet is my backend subnet. Okay, good, there's only one there, already choose it for us. We have a virtual network, my VNet. All right, and in we leave everything here, default, we didn't change anything. User password, default disk, next management. I know we're networking. Next, my VNet, my backend subnet. Okay, go to management. Make sure that boot diagnostic is off. Okay, all right, so I think that's all we need to do. We're going to select review and create. Okay, when that's created, we need to create another VM.
Your recording has reached the maximum length. To replay your message, press 1. To delete and re-record your message, press 3. For delivery options, press 4. To send a fax, press 6. To cancel this message, press star. To send this message now, press pound or hang up.
Is that from your guys' site? Because I know it's not me.
To replay your message, press 1. To delete and re-record your message, press 3. For delivery options, press 4. To send a fax, press 6. To cancel this message, press star. To send this message now, press pound or hang up.
I think it is because of the recording.
To replay your message, press 1.
Oh,
To
crap.
delete and re-record your message, press 3. For delivery options, press 4. To send a fax, press 6. To cancel this message,
do we have to
press
do?
star. To send this message now,
we need to
press
do?
pound or hang up.
Recording this meeting.
Martha's doing that. Do you want me to tell her to stop it?
Something. She has sent some. Said
Your
some kind
message has been sent.
of,
Thank you for calling. Goodbye.
Okay, hopefully it goes away.
Yeah.
That is weird. Okay.
Yeah, it is.
That's weird. All right, so that is creating, okay, that one we're waiting. Let's just go create the second VM because they want us to create 2 VMs. So this one is going to be my VM2, creating the same one, same resource group, my VM2. That is weird, but okay, my VM2. Yeah, my VM and my VM2. So, okay, we got my VM2. Make sure this is in Central US. We are keeping everything the same. The username password is the same as your user and password. Azure 1, 2, 3, 4, 5, 6. Okay, got all of those in. All right, and then we go to the networking. Okay, it is tied to my backend subnet, VM2 IP. We are good there. And the management, we're going to make sure this is off. That's what they want to make sure we have that off. Okay, let's upgrade the first one, but okay, we'll go ahead and create the second one. And let it create. So we're waiting in progress. Okay, so we have 2 running. So let that come back. Okay, the first one came back. We have, okay, so go to resource. So, okay, so we got my VM came back. So my VM came back. We need to run a script here. So the script is to run, okay, so, not that one, not that, okay. So this is the script we're going to run. The first one that came back as my VM. We are installing IIS on that particular VM. That's what we're doing. So we're going to run that one. The first one came back, so we know we can do that. So that's doing that. We're waiting for, okay, VM2 to come back. So what running those things here is where we are at. We just added subnet. We just went through that. We added subnet. We created 2 virtual machines. So we already did that. We're going to install IIS for testing. So we went into, we are in the PowerShell. This is the first one we're running because we only have the first VM came back. So location, mine, so if you create yours in a different location, you need to change the location, whatever your location is. And if you name your VM differently, this is where you need to change the VM name and the location, okay, to make sure this script go through. So after this one go through, we'll do that for VM2, okay? You need to do that, because you need to have 2 machines to add to the backend server. One doesn't make sense, right? If you have a pool, means you got to have more than 1. In the real world, you'll have 10 or 15 in there. Is what we will do. All right, so that's where we're at. Just want to show you where we're at. All right, we are Okay, this one's still running and this guy's still going. So that's a lot of installation stuff. Mhm. There we go. My second one come back as well. My VM2. Okay. But we can't do anything yet because the installing IS hasn't come back yet. Okay, so when that come back, this is just so we know what we're doing. So this, we're going to run this too. It is installing IIS on those VM, the two VM we created, which will be my VM and my VM2. Once we do that, we're going to add those to your back-end server pool. So we're going to add my VM and my VM2. So those two will be in our back-end pool. Okay, so you'll have VM1 and VM2 here as our back-end pool. Then we go create a storage account, and we're going to add the diagnostic. Diagnostic log is going into that storage for anything we created in the app gateway, going through the app gateway. Then we are going to test that application gateway using that front-end public IP. If you see this result up, that means that you can select all resources in the search box, copy the public IP, and then paste it into the address bar like we always do. Verify that application gateway was successfully created and it can successfully connect it with the back end. So that's what we're going to do. That's what we're doing. Just to get you an idea of what we're doing. So we are not there yet. We are waiting for this app gateway to be able to do that. But before we can do that, we have to have IIS on both sides. So that's what we're running the script to run that. But when we're the second time, you got to remember you got to change the VM name and make sure you change the location if you're not using ECUS. Oh my God, my machine is slow today. Okay, so that's what we're going to be doing as long as they come back. Thank God it came back. I was getting worried at that point. Okay, now we are going to do the second one. So notice that change the name of the VM and make sure the location is correct. As you can see, this take a while. So let's go ahead and run that. You want to see true, okay, okay. If you see false there, we have a problem. Is anybody trying to do it with me, or if everybody just watching? No, no one? Because this wasn't an original schedule. We add this one because you guys requested, so I just wanted to make sure you guys had a chance to try this, or is that you tried to implement at your site, anything like that? But if you're trying to implement it, and when you start doing it on your site, when you start gathering the requirements and all that, if you have a question, you know where to find me, so, okay? No joke, they're taking their time. Okay. Oh, gosh, thank God it's back. All right. Now we need to go into all resources in the portal, and we are going to select the My App Gateway. Which is the application gateway. We should only have one gateway. So we are going into the gateway we created, the My App Gateway. And we are in the here. So in the My App Gateway, under the settings, we're going into the backend pool. We're going to select the App Gateway backend pool. We already created rules associated with it. Okay, so here we have a target. So under the target, we're going to select virtual machine from the drop-down list. Select virtual machine. And the virtual machine, we are going to select my VM and select my VM2. Okay. And associated network interface card for my VM. This is for, okay, sorry, VM2. Okay, so that's only the only one there each, so there's no much where you can have it. We don't have a lot of choice there. And we are going to select save. There's not a lot to go wrong either, right? So, but that's deploying. We're going to create a storage account. So when this is still running, we can go ahead and do it. So we'll go into create a resource, or in the main menu, just go into storage account. So I'm just going to click storage account from the main menu. We have one storage account, but they want us to create a new storage account, resource in the same resource group. So we are going to click and add for the storage account. In the storage account, you are going to use the existing resource group, which is my resource group AG, which we've been using. And we are going to create the name of the storage account, which is my AG, storage one, accept all the default value. And we are going to click review and create. Validation pass, we're going to create. So there, once we get that, so what we've done so far here, we went into all resources in the app gateway. So that's where we want to add the 2 VM, whatever you want to add to the backend pool. However many VM you want to add, you can add as many as you want. After we did that, now we went and create the storage account. So storage account is where we're going to store our diagnostics log for the app gateway. Okay, so we just created the storage account. It's still working on it, but when it comes back, we are going to the app gateway, our application gateway we created, and we are going to let diagnostic logs and say, hey, store my diagnostic log in this storage account. So when you create a log, right, the file is going to grow and grow and grow. So we have to have somewhere it has to, either you can attach a storage or you can attach a disk, or you have to do something to make sure that the log has somewhere to go. So that's what we're going to do. Hang in there. We are almost there. Okay, your deployment is complete. Once deployment is complete, now we are going back into all resources. We're going back into our app gateway. We only have one and only application gateway. In there, under the monitoring, we should see diagnostic settings. Go into my diagnostic settings because we already have some stuff in there. Okay, so we're going to add a diagnostic setting. And the name of our diagnostic setting. My diagnostic settings. I'm just going to create one already. So GNO. And we want to select archive to a storage account. And we are going to go into, I don't have any maybe storage account isn't done yet, I think. Yeah, storage account is not done yet, that's why. We have to wait till storage account to come back. I was too excited. All right, it is there. So I'm going to just get back out here just for a second to make sure. But so we'll go back into the app gateway. We go back into monitor diagnostic settings. We're going to add a diagnostic settings. Diagnostic. Archive to storage account. Oh, give me a break here. Storage account. It better show up now. Why do we not have a storage account? Okay, let me go back into storage account. It did not create a storage account yet. Oh, I have a storage account. It needs to be in Central US. Oh, crap. All right. Sorry, I was too excited. I created too fast. Okay, Azure Resource Group. It has to be in the same region. Okay, so here needs to be Central US. Okay. All right, we just have to recreate it. Sorry about that. We have to make sure it's in Central US. Okay. Storage account doesn't take that long. The other one takes a long time. Look like we're doing good. We are doing good. Right. I might get to do another one. All right, my deployment is complete. So I am going back into all resources. Well, before that, let's make sure my storage account is here. Storage account. Notice that, so you see what the first time I did a mistake, the location of the storage and your app gateway has to be the same location. Mine was in a different one, so I had to recreate it, okay? So that's a good one to know. All resources, go to app gateway. And We are doing so good with this now. I've already did like 3 times. Add diagnostic settings. Archive to a storage account. Then our storage account better show up. Okay, so it has to be the same region, then it shows up. Say put it in there is what we're telling it. We wanted all different type of logs here. We want application gateway asset log, access log, performance log, and firewall log. So we make sure that they're all on and archive to storage account. Okay, perfect. We're going to click save. All right, we are good. Go back into the overview blade of the application gateway, and you see our front-end IP address, front-end public IP address. That is what we are going to open up a new browser page. Okay, we're not doing something here. We just need the IP address. Okay, we don't need the whole thing here. I need to use the IP address. Just need the IP address. There we go. We see my VM2. So that tells you that it went through the gateway. The application gateway is working the way we expect it to work. All right, so that's what we just did. I know there are a lot of things that we did here. I just wanted to recap what we did because we went through a lot of different things that we did here. So the first thing we did is we created a application gateway. Right? We created the application gateway, and then when we create the application gateway, we need to make sure that it is using Windows firewall. That's why we went and install IIS on the VMs, and we went and installed IIS on the VM after we create the gateway. And once we have that, we need to make sure we add a backend pool with 2 VM. We create the 2 VM. We add a subnet, and we make sure that within the subnet, same subnet, we have a 2 VM. We put the 2 VM in there. We make sure that IIS is installed on both virtual machines that we created in the backend pool. Then we create a storage account to store the logs for the application gateway. We create that, and then we went and test the application gateway to make sure that it is going through from VNet 1 to VNet 2, that they are communicating. So that's why we saw that my VNet 2. By using that is a front-end IP address that we just used to do that. So that's what we've done so far. Any questions, concerns, burning desires? Everybody good? Seems like we got a little bit of time, so if we still have time, but let's go back to the PowerPoint. Okay, so I don't think we have time to go through to do this, but the next one is talking about different networking routing overview. We're talking about system routes. We have user-defined routes, routing example, creating a routing table, create a custom route, associate the route. So system route is a direct network traffic between a virtual machine and the on-premises network and the internet. So traffic between the VMs in the same subnet, between VMs in different subnet in the same virtual network, or data flow from the VM to the internet, and communication between the VMs using a VNet to VNet VPN, and site-to-site and site-to-site and express route. Those are all considered system route. System route is system is going to define what is the closest, to going from, which is the quickest way to get from point A to point B. That's what system route is doing. However, so you say, well, we have a system route. Why do we need to do a user-defined route? We do a user-defined route if we have a dedicated server and stuff that we want to make sure that it's going to go through that, or it's for sensitive data. So we want to make sure that it's not going to route the way they want. We have a specific way we want it to go. That's why we create a user-defined route. A set of rules called routes specify how packets should be routed in a virtual network. You say, well, the system's going to take us this way. However, because this is sensitive data, I want to make sure that it's going to route this way. So that's why you create a user-defined route, a custom route that control that network traffic. We're telling exactly the network to go from this point A to point B to go there. Here's your stops. Here's your stops. Here's your stop. So each time you stop is your network. It's a hop. So because it's so far, the distance is so far, they cannot go from A to B directly. They have to stop multiple. Like if I fly airline, right? If I'm going to fly an airline back to my country, I have to stop it from Florida, goes to New York. From New York, then it goes from New York to, depends on what airline, but New York to China, Hong Kong, and from Hong Kong, then go into Bangkok, and from Bangkok to Burma. So that's a route. However, that is a system-defined route. But if I don't want to do that because I want to visit Japan, I'm going to fly here in Japan and UK. So I am going to fly to New York. From New York, I'm going to fly to UK. From UK, I'm going to fly into Japan. And from Japan, I'm going to fly to Bangkok. So if I want to fly differently, that's when you're defining that's your user-defined route. Every stop that I'm doing, that is a hop. We call a hop in a network. Okay, so let's talk about routing examples now. That is our DMZ subnet. We create a routing table, create a custom route, associate the route to the subnet. We did some of those in the previous one. Here's my public subnet. So it goes to the DMZ subnet to have a private subnet comes out. So this is you using the gateway, using the subnet to make sure that from public, and notice that a private subnet, here we're doing 10.0.0.0, this is 10.0.10. So but we are in the same address range. So the public subnet, private subnet, but we have two different subnet. So creating a routing table, you can go and create a route table, and BGP is what we did. We just disabled at the time we create a route, but if you create that BGP is Border Gateway Protocol. It is a standard routing protocol to exchange routing and reachability information between two or more networks. Routes are automatically added to the route table of all subnet with BGP propagation enabled. So it depends on how you want to do, your organization wants to use that or not. In most situations, you will want to enable BGP route propagation because it is more efficient. And we can create a custom route. That's what we did. We create a custom route and we use a virtual appliance. Okay, so that's what we did. We created a virtual appliance, and then notice that you have to have next hop, So this is a little bit more, you do have to have some network background to understand all this thing here. But think of it also as that route table, just like you want to go from one place to the other, like I was giving that example about airline. The same thing, that's pretty much the routing is doing that for us. Subnet will be associated, so the public subnet will be associated with the routing table. Okay, so we did the routing. So the one that we didn't do is the load balancer. You do have a lab in there for you to do. If you want to go, you can do that on your own time. If you want to do that and know more about what the load balancer does. So Azure has our load balancer. We have public load balancer, and we have internal load balancer. And load balancer, as KUs, there's backend pool. We have load balancer rules, session set persistence, and help probes. So this is, our picture earlier is the same thing. Here we have a front end. This is a request coming from the front end. It's going to give it to the load balancer. Based on those load balancing rules, load balancer is going to go through that. But before it goes through the rules, the first thing it goes to is it's going to check the health probe. So what the health probe is looking is that in the backend pool, it's going to make sure that which VMs are running. If one of the VMs shut down, it's not going to send it to, it doesn't want to waste your time, send it to the VM is down. So they make sure health probe is checking it, every second. You can make it check every second, every 5 seconds, whatever, that to make sure that the VM is up and running. You check the health. So the load balancer is going to only use what in that backend pool is when the ones are healthy only is that they can distribute to. So it distributes inbound traffic to the back end using a load balancing rules and health probe. So first we check the health probe. It's okay, but we have 5 VM in the backend pool. This one we have 3. 3 in the backend pool. What type of balancing rules should I apply? So balancing rules can be, you can apply that when a request comes in, all 3 VM in the backend pool has the same privilege, which means that they're just evenly, you can distribute it. Or in that backend pool, we have 3 machines, and let's say one machine is a critical machine. It's a priority. So we say, hey, out of this 3, this one machine, we are only going to allow someone come from a specific IP address coming from request coming from that. That's the only one can go to that machine 1. VM1. So that's a similar type of backend. Those are backend load balancing rules. You can set different rules. Or you can say that no matter what, this one machine, we only want, as always, dedicate 50% of the VM for a connection coming straight to them, but they only participate the other 50% in the back-end pool. So you can set up all kinds of rules in there. You can have all the inbound, outbound rules. You can also extend Active Directory into the cloud. So 2 types we have in the load balancing is public load balancing and internal load balancing. So public load balancer is public is going out to the internet, which is port 80. So you can map these IP addresses comes in. Let's say you have an application. Your application, a website, has 3, you distribute it to 3 virtual machines. Your public load balancer is going to decide which one to go to. It depends on, and if they all have an even, in this case, they seem like they all have a even permission, which means that the load balancer is going to decide to go to 1, 2, or 3. No one has higher priority than the other. It's going to it's going to distribute the connection comes in evenly. This VM1, the first goes to VM1, the second one request comes to go to 2, third goes to VM3, and it'll keep going in around and around. So that's a public load balancer using port 80. And then we also have internal load balancer, directs traffic only to resources inside a virtual network that use a VPN to access Azure infrastructure. So this is a VM. We had created a VM with a Windows Server 2016, which we just did, right? We have that VM, and then we have a SQL database somewhere here. And so these VM that need data from the SQL, that's we call internal load balancer. It's only internally. They are still inside, inside Azure, so pretty much inside the wall, so to speak. And that's, you can do the internal load balancing. Okay, and we can load balancing SKUs. Type, we have internal public. SKU is basic and standard. Load balancers support both basic and standard SKUs. Of course, standard is a little more expensive, so thicker SKUs are like a license, right? Are not mutable. Load balancer rules cannot span 2 virtual networks. It's only in 1 virtual network only. No charges for that basic load balancer. Load balancer front ends are not accessible across global virtual network peering. So there's rules that we got to have that under control. The backend pool, you can distribute a traffic to the backend pool. Contains the IP address of virtual NICs are connected to the load balancer. the load balancer rules, you can set up different, map a front end IP to a port combination, a set of back-end IP addresses, and you can also set port combinations. So inbound network rules, so it goes straight, the load balancer goes straight to the VM2. If you're using, that's using inbound net rule, network address translation rule. If you're using a load balancing rule, it will go to the probe first. We talk about it. Go to the probe and make sure it's healthy. Then it goes to the load balancer backend pool. And then from the backend pool, it will go to the VM. Whatever in the backend pool is available, it go to that VM. So there's a couple ways. It depends on what you're trying to do. You need to do that. And session persistence. So session persistence means that when a client sent a request, so first they just had a username and password, you're trying to authenticate. So it comes in at that, okay, it went to the load balancer sent it to the VM1 and say, okay, maybe you have the right username and password. So now I wanted to query something. When I come back second time, it knows that to go to the same virtual machine. You don't want to go to a different virtual machine and have to re-authenticate you all over again. So that's what we call session persistent. So if I connected, it sent the load balancer sent my request to virtual machine 1. If I query whatever I do, it's just going to go to virtual machine 1. It's not going to switch me to 2 or 3. It will keep me in 1 to make sure that we have session persistent. So make sure that you go to the same one. Help probe is going to allow load balancer to monitor the status of your app and make sure that app is running successfully. And it will let you know if you have any other problem. This is a probe to establish a successful TCP connection using that. Azure Traffic Manager. Okay, so we just talked about load balancing. What is Traffic Manager? You can do priority routing, performance routing, geographic routing, weighted routing. We can implement a Traffic Manager profile, Traffic Manager endpoint, and what is a Traffic Manager versus load balancer. When should you use Traffic Manager? When should you use load balancer? We'll look at that as well. So Azure Traffic Manager. So here allows you to control service endpoints around the world. So when the connection comes in the DNS query, we set up a DNS earlier. It goes to the DNS services. DNS server is going to send back the query information. Okay, so before it goes back there, it's going to go to, if we have Traffic Manager, goes to the Traffic Manager, and Traffic Manager send back to the DNS server response, DNS server send it back to the browser. So what it is the Traffic Manager client do not connect directly to selected endpoint. You can do that, but client is not connecting through a Traffic Manager. So Traffic Manager is not, it doesn't go through. You didn't browser connect. Okay, Traffic Manager site, you're right, it goes to there. It doesn't do that. Remember when we were doing the load balancing, that's what load balancer will do. Load balancer will go directly to, to whatever you're trying to, go to the back end pool. This one, it doesn't do that. It sends it back to the client. So it's a very different approach. Control distribution of user traffic to service endpoint around the world. You can use DNS to direct end user requests to the most appropriate endpoint. You can select endpoint based on the configure traffic routing methods and provide endpoint health checks and automatic endpoint failover. Traffic Manager features and improve the availability of critical application. It improves responsiveness of high performance. It's upgrade and perform service maintenance without downtime. Combine on-premise and cloud-based application. It can distribute traffic for large, complex deployment, create profiles for different routing scenarios, and using several routing algorithms. So what it does is you can set up either priority routing. So in a priority routing, you can tell that, hey, when a request comes in for this particular server, give them a priority, route that one first. So that's what priority routing goes. Okay, you have priority routing. The next one is performance routing. And then what it does is calculated. It depends on we're going to execute it in West US. It's going to take 15 milliseconds. But go to North Europe is 75, East Asia is 150, and it will route to it will take the lowest range that you can have. That's performance routing. Then we have geographic routing. You can also set up in the route table that, hey, when the connection comes from this particular location, always go to Germany only. Okay, so notice that nested profile means in one profile you have two different endpoints. It can be two different countries, two different locations. So we call that nested profile as well. But this is selling based on a particular particular geographic location. You're trying to route it that way. That's what you're putting in Traffic Manager. So Traffic Manager normally handles more complex type of managing your transactions coming in, or managing the requests coming in. Then you also have weighted route, a predefined weighting. So weighting is more like it's going to calculate between the CPU, the CPU time, memory time. So it's going to calculate your transaction time, what it's going to take, and that depends on that. It decides give you different weight. Okay. So implementing a Traffic Manager profile, you can go on and create a Traffic Manager profile from create a resource. We can go ahead and do that. And you can enable or disable your profile at any time. And we have implement the Traffic Manager, same thing. We have to have this target. We have the source. That's very similar to what we did. And Network Traffic Manager, we did like Azure Load Balancer. So here is the Azure has several options to distribute network traffic. Using isolation or combination technology, we are using Transport Layer 4 if you're doing Azure Load Balancer. Traffic Manager is using the DNS. Protocols in the Azure Load Balancer, you can use any. Traffic Manager, it is going through a internet, so you have to use HTTP or HTTPS protocol only. The endpoint, Azure VM Cloud Services role instance. Endpoint for Traffic Manager, it can be Azure VM, Cloud Service, Azure Web App, and external endpoint. So if you're using Web App, definitely it has to be Traffic Manager. Azure Load Balancer does not do that. Network connectivity, both internet-facing and internal VNet-facing. Traffic Manager is internet-facing only, so going out only. It doesn't do internal networking. So there is a lot for the balance of Traffic Manager. Like I said, we don't have time left to do that, but you guys can do that. There is step-by-step in there. If you're going through step-by-step and you have any problem, you know where to find me. Well, this is our last session. It comes to the end, even though we were having so much fun. Appreciate you guys being patient with me. Appreciate you taking all the 15 sessions. And hopefully, I will see you guys in the near future classes. Enjoy the rest of your day. Stay active with Azure. I give you so much resources. Please take advantage of those. If you want to learn, it's all up to you. Like I said, always, you don't have to learn 100% every day. If you just even learn 1% or 0.001%, if you do that in 100 days, you'll be 100% you learn than what you started with. So hopefully all these sessions have been helpful for you, and hopefully you're going to take this as a platform, and all you can do is go up, right? You can go forward with Azure, and good luck with all your projects. If you need anything, you know where to find me. All right, guys.